Hi everybody. So today, this is the first video. It's a Monday of the week starting on July the 21st. So it is July the 21st. This is the first video for this week that refers to Module 3. The assignment for this week is related to improving satisfaction with car part delivery. This particular module, Module 3, is one that I think reflects most closely what someone would do to employ this model-driven data analytics approach in organizations, to analyze data in organizations and explain the findings of the analysis and make decisions. So as with the previous module and all the modules in this course, the assignment is due by 1 p.m. on Friday, and you should post a commentary like most of the class already did for module 2. You should also attach the .prj file that you created using WordPLS and a .png file with the screen snapshot. One question that may come up is whether you could get an A if you submit an assignment late. So let's say you submit all the assignments online on time and one of them was submitted late. Yes, you can get A if you do that. If you look at this grade conversions table, so you get an A with 90% of accomplishment or above. Since we have 6 assignments, each assignment is worth roughly 15% of the grade. So if you submit one late, and I take that as say being worth 7%, then you're still at and you have all of the other assignments submitted on time, then you're still 90 and above, so you still have an A. And I will always consider late assignments. So if you don't submit an assignment on time, please submit it late. Late is better than never. Okay, from Module 2, we may have had some submissions that were late. Most people submitted on time, so it was actually a good number of people already submitted on time. And I had noticed that there were a few that did not submit on time, but I think they submitted already late, which is the right thing to do. So those late submissions will be considered. It looks like Teresa did submit the 2 files again. So it shows a new submission by Teresa. So let me see if I can find this additional submission. Okay, so this is not a correct submission, right? So one of the files, the PNG file, did not come through, and so this is an incomplete submission. I'm required by law not to discuss any student's grade or performance. I'm just trying to be as helpful as possible here, as long as I don't say this particular person received this grade in the course. Now, if someone has done it incomplete toward the end of the course, I may even, everything else considered, that person may receive an A. So I'm just trying to be helpful here, not put anybody on the spot or discussing individual grades. It's okay, I'm trying to, okay, so let's see. yeah, I guess we got to the end. So this was a partial submission by Teresa, because the files that were attached were not the right files, right? So it was an incomplete submission. Again, if you can correct that, that will be an after the deadline correction, but it still counts. And already we have submissions for module 3. So we already have 2 submissions. They look like they are complete. Yes. So good. So the class is performing well. One thing I wanted to discuss with you today, in addition to where we are in the course, which I just did, is I want to answer a question that you may be considering, and that many people have, which is, what is the minimum sample size that you need to do an analysis? And as it turns out, we looked into this issue and we published on this, and the number is 7. Okay, and what we did was we looked at this phenomenon here, which is called in financial circles the yield curve inversion phenomenon. So this is this graph shows the 10-year Treasury yield minus the 3-month Treasury yield over time. And as it turns out, whenever it inverts, it goes below 0, it then uninverts, and then we have a recession. So it inverts, uninverts, recession, and inverts, uninverts, and recession. And this always happened. Again, even for COVID, it inverted and then uninverted, and we had the COVID recession. And here's what is happening now. So it inverted, and it's uninverting, but the uninversion is not taking off. So it's an unusual time that we're living in now. But since this inversion and recession phenomenon, so an inversion is followed by a recession soon after, since this happens all the time, it has happened all the time, every time this inversion happened, there was a recession. The correlation between the inversion occurring and a recession occurring soon after is 1. So if you have 2 variables and the correlation between them is 1, and they are collected at different points in time, and they are clearly not the same variable, right? Because of a correlation of 1 would suggest collinearity. It would lead to a full collinearity variance inflation factor, very high, certainly higher than 10. So the question then is, how many times does this situation in which 2 variables are correlated, how many times does that have to happen for me to be able to say that what's happening here is not a coincidence, an odd coincidence, not just an odd coincidence, it's a statistically significant pattern, and that is 7. So and the paper that discusses that is a paper that I co-authored with Augustine Tarcom, a professor of finance at Texas State University in San Marcos, and we answered that question: how many times until a coincidence becomes a pattern? The case of yield curve inversions preceding recessions, and the magical number 7. So we essentially concluded that for what seems to be a coincidence to be no longer a coincidence but a statistically significant pattern, it has to happen 7, which is essentially the answer to the question, what is the minimum sample size you need to test a relationship, and the answer is 7. And for the same reason that we discussed here in this paper. You don't have to read it. This is not really part of the course. Is actually an add-on to what you're doing already. It's just something else that I'm providing. That's interesting. So it is 7. Interestingly enough, if you go to WarPLS and you go to the option Explore, which is available even if you haven't read any data, and you go to Explore Statistical Power and Minimum Sample Size Requirements, and you assume that the minimum absolute significant path coefficient in a model, it could be a model with 2, 3, how many variables, as long as one is as strong as close to 1, and I'll put 0.99 because that's the max here, and I click on Enter, it gives me a minimum required sample size of 7 using the inverse square root method and 6 using the gamma exponential method. And it is related to this article because in the article, if you click on the article, you will see that in our mathematical derivation, we got a number that was actually 6.180, which we rounded up to 7 since it's the sample size, right? Sample size has to be an integer. So the inverse square root method, the gamma exponential method by WarPLS gives 6 because that's the closest integer to 6.18. So it also, and so this is a different approach, but this is the answer to that question. Then the minimum sample size you could possibly have for an analysis would be 7. Okay, this is what I had for today. This week, this is the first video of the week for module 3. Thank you for watching.